Hi folks, welcome to day 19. Today we're going to be learning how to graph the function y equals ax squared. So yesterday you learned some vocabulary which took us a little bit. We learned about vertex, which is the bottom of a function or the top of a function, the point where the function changes direction. So it's usually either at the bottom of a valley, all right, or the top of a hill. We also learned about the axis of symmetry, which always goes directly through the middle of the vertex. We learned about the domain, which for our case is always all real numbers. And we learned about the range, which is always either y is greater than or equal to 0, if a is greater than 0, or y is less than or equal to 0, if a is less than 0. So that's like a recap of the vocab that we went over yesterday. We also found out how to go in and evaluate our function. Today, we're going to be taking those evaluations, those t-charts, and we're going to be graphing them. So the first thing I'm going to do is I'm actually going to show you how to turn your blank Notability page into graph paper. All right, everyone, or at least the vast majority of you, have iPads that you're working on. So what you're going to go and do is in your Notability, if you're trying to do a graph problem, you're going to click this green, or not green, this blue, what is that, wrench symbol? The pen I'm holding is green, for the record, which is why I said green. But you're going to click that gray, or now it's gray, the blue wrench in the upper right-hand corner. Click on that blue wrench, then you click on paper. And there's lots of different papers you can use. Doesn't really matter too much, but you're going to want one of these ones that have grid lines. I'm going to choose a little grid lines for today's video, just so that way it makes it a little bit easier. But again, all you have to do, click that wrench, regardless of what color it is. Click the paper button, and then you're going to click one of these down here that has the grids. You can see the bigger the grids in the picture, the bigger they are on the screen. I'm going to use little ones because it makes it a little bit easier. All right. So, if we are trying to graph our function, let's go ahead and work with an example function. Let's say we have negative 2x squared. Yesterday, we learned that we should have a t-chart. And the reason why we should have this t-chart is because it's actually going to make it so much easier for us to graph our function once we have the t-chart already completed. So when you're graphing, you're going to always want to have points on either side of your axis of symmetry. You want that so that way you're showing people visually that you're working with a symmetric function. In order to show that, we're going to be working with negative 3, negative 2, negative 1, 0, 1, 2, and 3. All right, this is just like what we did yesterday. Then what you do is you take your x value and you plug it in for x. So for my first one, negative 3, I'm going to go ahead and plug in my negative 3 in for x into my equation. So then I have negative 2 times x squared. Remember, because of PEMDAS, we're going to have to first exponentiate first and then multiply. So we have negative 2 times negative 3 squared. Negative 3 squared is just negative 3 times negative 3, which is just 9. And negative 2 times 9 gets me negative 18. Since I am working with a symmetric surface, I also know that positive 3 is going to be negative 18 as well. I'm going to do that same thing with negative 2. So we have negative 2 squared times negative 2. Negative 2 squared is 4, so we have 4 times negative 2, or negative 8. And again, that works for both positive and negative 2 because when you're going through, this is a symmetric function. All right, last but not least, we have our negative 1, we have negative 2 times negative 1 squared. Negative 1 squared is just negative 1 times negative 1, which is just 1. Negative 2 times negative 1 is just negative 2. And 0 is always 0, or at least when we're working with our basic y equals ax squared function. 0. 0 input for x is 0 output for y. Alright, so this is what we did yesterday, was this portion of it. We also talked about domain and range yesterday. Alright, what we're going to be doing now is taking these 6 points and graphing them on onto a graph. So I'm going to go ahead and get rid of all this beautiful work because we don't need that. Alright, so when you're graphing these, if you're doing them on actual graph paper, that's fine. You don't have to do it on graph paper. I just think it's a little bit easier. So you can also see how terrible I am at drawing straight lines, but that's okay. So we know that we're going to be working with our x values from negative 3 to positive 3. And our y values are going to be from negative 18 to 0. So that's why when I've drawn this, you can see it's predominantly in the bottom portion, in this negative portion. All right. So I'm just going to have each tick mark be 1. But it's really important that you're actually labeling them, so that way when I'm going through it, if I'm looking at these, I should be able to really easily see whether or not you've graphed it properly just by looking at it. And I'll know based off of what you put as each tick mark, because you can't jump from, like, let's say I didn't make each tick mark be 1. Let's say I just wanted my tick marks, instead of 1, maybe I want it to be like 7, right? Which wouldn't make sense for this one. But you can't jump from like 7 to then like 13 to then like 24 or 25. You know, you can't just jump around randomly. You have to make sure that you have these all the same value each space you're moving. So if one box is going to be 1 on one side, it has to be 1 on the other side. All right. So I'm going to count each box on my x-axis, or each tick mark, as 1. I'm going to try and do the same thing for the underneath side too. So for the y-axis, I'll also have each space be 1. I think that just makes it a little bit easier. All right. So your typical problem would ask you to graph y equals negative 2x squared, then describe the domain and range, and identify the axis of symmetry and the vertex. That's going to be what your problems are asking for. For me, when I see a whole bunch of instructions, I get a little intimidated because I'm like, wow, there's a whole bunch for me to do in this problem. My recommendation is don't get too intimidated and just try and take it one piece at a time. So the piece that we started with was this graphing piece. All right. So now what we're going to go ahead and do, I'm actually going to erase the stuff on the underneath side of the x-axis. And we're going to go ahead and graph our points. So at x equals negative 3, so over 1, 2, 3, then our y is negative 18. So if we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18, all the way down here. So I'm going to have 2 points down here, one at positive 3 and one at x equals positive 3 and one at x equals negative 3. At x equals positive 2 and negative 2, I see that y is negative 8. So I go to the left 2, So I'm going to the left 2 and then down 8. So down 1, 2, 3, 4, 5, 6, 7, 8. And if I made any extra like marks, I can go ahead and erase them. And last but not least, we have positive 1 and negative 1 at x equals negative 1. Y is negative 2, so I go to the left, negative 1, and then I go down 2, all right? So that's how we get a spot here, or a point there. Similarly, we go to the right 1 and then down 2. That's how we get our point there. And our final point is at 0, 0. Once we've done all of the point plotting, then all we have to do is connect these with a curve. Now I'll let you know all quadratics will either look like a U, like a smiley face, or it'll look like an upside down U or a frowny face. All right, all of your quadratic graphs are going to look like either a U up or an upside down U. So we did the graphing. Oop, we did the graphing, check. All right, now comes to the describing domain and range, which we did yesterday. So remember, domain is always that x is all real numbers. So you can either say x equals the double-lined R or x is all real numbers. All right. Your range, remember that's your y values. If we look on our big graph, you can see that if I was trying to find where my function exists, if I'm looking up here, I can see that it doesn't exist up here, right? When y is bigger than 0, it doesn't exist. So our range is that y is less than 0. Or, said another way, since our a is negative 2, a is less than 0, and whenever a is less than 0, our range is that y is less than or equal to 0. So our domain is that x is all real numbers, and our range is that y is less than or equal to 0. So we describe the domain and the range. Last but not least, we're going to identify that vertex and axis of symmetry. Your vertex is always that center point. All right, it's always this center point that marks when your graph is changing directions. So you can see that the graph is going up, it's increasing to the left of the vertex, and then it decreases to the right of the vertex, so where it's changing direction is the vertex. All right, so we say that is our vertex. And I'll let you know for y equals ax squared, so anything that we're working with like that, your vertex is always going to be at 0, 0. Your final part, now that we've done the vertex, is to deal with the axis of symmetry. The axis of symmetry is just a vertical line straight through the vertex. All right, I always draw it as a dotted line because it helps me remember where it is. But there you go. There's the axis of symmetry. So you already did all of the hard parts of this. All right. I know some of you are going to be confused with this. The hard part of this is making this T-chart. We learned how to do that in yesterday's video, and I strongly recommend you go back and look at that again if you got confused. All right. Then what we did today is we took this information and we just plotted these points on a graph. After we plotted them on the graph, we connected all of our dots together. We described the domain and range just like we did yesterday. The domain for all of your problems is always all real numbers. And your range is either y is less than or equal to 0, like we have here, because a is less than 0. Or if a was bigger than 0, so if a was a positive number, any positive number, even if it's a fraction, even if it's a decimal, as long as it's positive, if a is a positive number, then your range is that y is greater than or equal to 0. The only two pieces that we did differently today is we actually did something with that vertex and axis of symmetry that we learned about yesterday. We identified the vertex on our graph, which was just that center point, the top of the hill, right? Your vertex for all of your problems that you're working with today are all at 0, 0. That's all of your vertex. Your axis of symmetry for all of your problems today is always at x equals 0. So a dotted line right along that y-axis. All right? That's always going to be the case because all of your problems today are in y equals ax squared form. Next week, your vertex and axis of symmetry will change because we'll be working with harder problems. This week, though, we're just working on these types of problems, these simpler problems. So that's going to be what we'll be working with on our problems today. All right, so other than that, go ahead and try out. I do have another example written in my written notes if you want to take a look at that. But other than that, all you're going to be doing today is you're going to take your work from yesterday, right? All of these, the hard work you did yesterday with these T-charts, and you're going to be taking those T-charts, graphing them, and then identifying the axis of symmetry and vertex because you did the domain and range yesterday. All right? That's all I got for you today. Thanks for listening.